Good afternoon, guys, and welcome to today's session. There on the board, I wrote questions that deals with electric circuits. So as we prepare for the exam, so I would like us to deal with those three questions for now, and then we'll continue doing more of them in a few. So let's delve into the whole thing and answer the questions asked. Question number one, or rather the statement says, or rather reads as follows: a battery with an EMF of 20 volts EMF of 20 volts and an internal resistance of 1 ohm is connected to 3 resistors as shown in this particular circuit. So as it can be seen, this is an EMF here, and then this is a resistor internal, and then we have these 3 resistors outside in the external circuit. Now let's read what the questions are asking. Calculate the current in the 8 ohm resistor. 8 ohm resistor is this one. So if we calculate the current here, we need to pay attention to this particular statement. The circuit has a parallel connection here, and this resistor is there alone. So what this simply means, it says that this circuit will be the one, this resistor is basically in series. So basically the current in this particular 8 ohm resistor is a total current in the whole circuit. So we can use the formula of EMF to calculate that particular current. As we can say, solution, and then we say EMF is equals to current into, and then that. However, before using this particular thing, we realize we have not found the total resistance, which is this one, or rather the effective resistance of the whole circuit. We can come here and say, since there are 2 resistors that are connected in parallel, I'm going to use 2 equations such that you can see how we can, or rather formulae such that you can see how you can find these questions. I'm going to use the one that maybe your teacher taught you in school. 1 all over R total parallel is going to be 1 all over R1 plus 1 all over R2, which is going to be 1 over 5 plus 1 over 10. And then this is just going to be, let's use a calculator for 1 over 5 plus 1 over 10. It gives us 3 all over 10. This is basically 1 over R total parallel. It's not what we want. We want the effective resistance across the parallel circuit. So when we invert this, we find R total is going to give us 10 all over 3, which is approximately 10 over 3, 3.33 ohms. Now let's use a different method to find the same answer, which is the method that I want, or rather love. So in this particular method only works when we have 2 resistors in parallel. So we will be saying R total parallel is going to be R1, R2 all over R1 plus R3. R2. Do not, I urge you, do not put R1, R2, R3 and say divided by R1 plus R2 plus R3. Is going to make you get wrong answers. Please, it only works when we have 2 resistors connected in parallel. Now let's proceed. I will have 5 multiplied by 10 all over 5 plus, is it 5 by 10? Yeah, 5 plus 10, which gives us 50 all over 15, which can be simplified to 50 over 15, 10 over 3, which is approximately 3.33 ohms. So as you can see here, the answers are the same, different methods, correct. So you can use whichever one that you want to use, so long as you got the correct answer. Now let's go to our question that we were asked to find. We are not done yet calculating the effective resistance of the whole circuit. We just had to calculate firstly the total resistance across the parallel circuit. So we will say we found that across the parallel circuit RT parallel, we have 3.33 ohms, right? But R total across the whole circuit is going to be 8 plus 3.33, which is going to give us 11.33 ohms, which is the one that we are going to use there. So now let's check, substitute everything that we were given. EMF is 20 volts. I, we are looking for U, and then we have 11.33 plus, we have what there? 1 ohm. And then we will be having 20 is equals to I into 12.33, and then we'll therefore say I is going to be 20 all over 12.33. Our calculator. 20 divided by 12.33, it gives us 1.62 amperes. So that is our current. So I'm going to write it here. I is going to be 1.62 amperes. Now let's proceed to question number 2. So question number 2 reads, calculate the potential difference across the 5 ohm resistor. So now let's check. The potential difference across the 5 ohm resistor is basically the potential difference of the parallel circuit. So what can I do? Maybe what I can do is that I can find the potential difference here. All right. Or yes, I can find the potential difference here and then minus it from the EMF and get the total, or rather the one that is left is going to be the potential difference of there. Now let me just get something first. Okay, sorry about that. As I was saying, I'm going to start first by finding the voltage of this particular part here. Nonetheless, let's check here first. EMF is going to be equal to I into R plus internal resistance. But let me distribute the current. I'll have IR plus IR. I can therefore say this IR is going to give us what? Voltage external. Plus this IR is going to give us voltage internal. Then that is going to be equal to, sum of those two is going to give us the EMF. Now, let's calculate voltage internal first. So I'll end up saying voltage internal is going to be current multiplied by internal resistance. What is my current? I calculated it as 1.62 multiplied by the internal resistance is 1. So voltage internal is going to give us 1.62 volts. So this is internal. However, we were given here that the EMF is 20. So I'll say 20 equal to voltage external plus 1.62 volts. And therefore voltage external is going to be 20 minus 1.62. So how much is it? 20 minus 1.62. I get the answer as 18.38 volts. Right? So that is the total voltage of the external circuit when we exclude the voltage of the internal circuit. Now, remember, we found the current here, right? So by finding the current here, I can find the voltage here, as I said. So they did not say we should find it, but I'm going to find it. I should find the voltage across this particular resistor of the 8 ohm resistor. After finding this voltage, I'm going to minus it from the total voltage. Therefore, I'm going to get the effective, or rather the voltage across the parallel circuit, because the voltage across the 5 ohm resistor is the same as the voltage across the 10 ohm resistor. So because in a parallel circuit, voltage is the same. However, it is different on a series circuit. Then now let me just share this space to say voltage across the 8 ohm resistor is going to be 8 multiplied by what is the current? 1.62, and then I'll end up having I have 12.96 volts. So that is a voltage across the 8 ohm resistor. Nonetheless, now I'm going to say voltage total is going to be voltage across the series part, or rather the series connection, plus voltage across the parallel circuit. Why? Because the parallel connection, rather, this is a mixed circuit. Why? There is a parallel connection and then there is a series connection. And then we have our 18.38, which is equal to 12.96 plus V parallel. Therefore, 18.38 minus 12.96 is going to be equal to V parallel. And then let's check what is that. We end up finding that the answer is 5.42 volts. So we can say voltage across the 5 ohm resistor is going to be 5.42 volts. Yes, that's about that for this particular question too. I hope it makes sense. Let's proceed to the last question. So last question says the power supplied by the battery. Now let's check. I'm going to write the formulas of power that I have. We have P is equals to IV or VI, which is the one that I'm going to use. Or we have P is equals to I squared R, or we have P is equals to V squared all over R. So I'm going to use this one myself, and then I'll end up saying the current was given as was found as 1.62, and then the voltage, the total, everything is going to give us 20 volts. That is the total voltage that from the battery and everything. It covers the whole voltage of the system, including what is inside the battery. So hence they say the power supplied by the battery. So I'll be saying 1.62 multiplied by 20, and I have my power as 32.4 power watts. So that is question 3. Easy peasy. So when you meet such a question in exam, you better make sure that you understand the fact that this is a mixed circuit, and then how to calculate effective resistance across the parallel circuit, and then add in this one. That's what the first question wanted us to do. And then coming here, we saw that we have to find the total external voltage, and then calculate the voltage of the 8 ohm resistor, minus it from the external voltage to get this one here, and then power is just that particular thingy. And I hope this makes sense. Hope to see you soon. Thank you. Bye bye.